Polarization of light. This is a new concept in optics, and it is one of the very interesting concept since it has many applications. Now, let us try to understand the meaning of this polarization, and let us try to get the concept of it first of all. Now, in order to understand polarization of light, we have to look at the nature of light wave first of all. We know that light wave is a transverse wave. Not only that it is a transverse wave, but it is an electromagnetic wave. So what is an electromagnetic wave? An electromagnetic wave is a wave that has electric field and magnetic field vibrations as shown in the figure here. So in this figure you can see that the red transverse wave out here, this is the vibration of the electric field E. And the electric field is vibrating along the y-axis. You can see these arrows out here. These arrows are called the electric field vectors. Okay, so the electric field, as the wave is propagating along the x-axis, the electric field vectors are vibrating along the y-axis. The blue color wave here, which is perpendicular to the electric field, that is the magnetic field. The blue arrows represents the magnetic field vectors, and the magnetic field vector is perpendicular to the electric field vector, which means that the two fields are mutually perpendicular to each other and to the direction of propagation. This is actually the diagram of, this is how an electromagnetic wave look like. Okay, so always an electromagnetic wave consists of the electric field vibration and the magnetic field vibration, which are always perpendicular to one another. If you set your eye from here, let's say you're looking from here, you're allowing the light to enter your eye, then what will you be seeing? This is what you're seeing. Okay, this is what you're seeing. You're seeing that the magnetic field vector is vibrating in one direction and the electric field vector is perpendicular to it. Okay, it doesn't mean that the electric field will always be vibrating in this direction and the magnetic field will always be vibrating in that direction. No, it doesn't mean like that. All right, so it can be like this. The electric field can be vibrating along that direction, and corresponding to it, perpendicular to it, there is its corresponding magnetic field. Or it can be vibrating like this. Electric field along this direction, perpendicular to it is its corresponding magnetic field. Or it can be vibrating, like that. Do you see here? So this is the diagram or the picture of light, which shows the vibrations of the electric field and the magnetic field vectors. But it is experimentally found that only the electric component of light is responsible for optical effects. So therefore, we are not going to consider the magnetic field vibrations. We are going to consider the electric field vibrations only. That means the red color vibration only. Light in which the electric field vectors are vibrating or can vibrate along any plane, that is called an unpolarized light. Okay, so an unpolarized light has its electric field vector vibrating in more than one plane. All right, so that is how an unpolarized light look like. This shows the pictorial representation of unpolarized light. So here you have the light ray going in that direction. And then you have these arrows. These arrows are the electric field vectors which are vibrating on the plane of the board. The dots out here, can you see the dots? The dots out here represent the electric field vectors vibrating perpendicular to the plane of the board. So how many plane of vibrations are there here? There are two plane of vibrations. So since this has more than one plane of vibration, we can represent that take this to be an unpolarized light. So what is polarization? Polarization is nothing but the phenomenon of restricting the vibrations of light When we say light, we mean electric vector in a particular direction perpendicular to the direction of the wave motion. So if somehow we are able to restrict the vibrations, that means we cut off the other vibrations and we allow only one vibration. Okay, that means the vibration only in one particular direction. Then that method is known as polarization. Now, how do we get polarization, or how is polarization? How do we bring about polarization of light? We use special crystals like a tourmaline crystal. So this is the diagram. This is the figure, the picture of a tourmaline crystal. It can be of many colors. Okay, it can be black or it can be green, pink color, so on and so forth. So by allowing light to pass through such a device, the light can be polarized. And these devices are known as polarizer. Now, let us look at how light can be polarized. Mainly, there are two ways in which light can be polarized. Number one, polarization by absorption. So let's say we take a tourmaline crystal. So this blue color crystal here, this is a tourmaline crystal. And in the tourmaline crystal, there is a particular axis which is called the transmission axis. This is an axis which is going to be of importance to us. Okay, so let's say we allow unpolarized light to pass through the tourmaline crystal. So this is unpolarized light. You can see here that it has vibrations along the plane of the boat and the dots here which are perpendicular to the plane of the boat. All right. So let's say the intensity of this unpolarized light is I naught. Now what will happen? Only those vibrations which are parallel to the transmission axis can pass through. That means only the arrows can pass through. The dots which are vibrating perpendicular to the transmission axis cannot pass through. They get absorbed by the crystal. Okay, so what will happen when this unpolarized light is passed through the tourmaline crystal? We get light which is vibrating only in one plane. You can see the dots are no more visible out here. Why? Because those vibrations perpendicularly get absorbed by the crystal. So we have light which is vibrating only in one direction, and this type of light is a polarized light. And interestingly, the intensity of the polarized light reduces to half its original intensity. All right. So let us take a second tourmaline crystal. So let's put this tourmaline crystal there so that its transmission axis, the dotted line, is parallel to the transmission axis of the first crystal. Do you think that this light will be able to pass through? Obviously, I told you that only those vibrations which are parallel to the transmission axis can pass through. So you will see that this light is able to pass through and it reaches the eye of the observer. What is the intensity of this light? It will be the same as this, okay, because 100% of the light is able to pass through and reach the eye of the observer. Now let us rotate this second crystal so that now its transmission axis will become 90 degrees perpendicular to the transmission axis of the first crystal. So what will happen? Even this light, even these vibrations will be absorbed by the second crystal, right? Because these are perpendicular to the transmission axis, so they cannot pass through. So you don't get any light entering the eye of the observer. Okay, so this process in which light becomes polarized by allowing it to pass through a crystal is known as polarization by absorption. And for your information, the first crystal that produces polarization, this is known as a polarizer, whereas the second crystal is known as an analyzer. Basically, this analyzer, it detects the plane of vibration of the polarized light. Okay,